This application allows us to explore the hypergeometric distribution a bit more. So remember, the story for the hypergeometric distribution is sampling without replacement balls out of an urn. So in this sort of panel setup, we let W be the number of white balls, or whatever the success is, whereas B is the number of blue balls or the failures, and you pick out N of these balls. We're going to talk about this number of draws thing in a second. This number of draws slide just means it just tells the Shiny app how many observations we want to plot over here. It's not super important. For now, we're just going to leave it at 1,000, so we're just plotting a lot of values from this random hypergeometric. And this is just, this N, W, and B is just, or W, B, and N is just allowing us to set the parameters of the hypergeometric. So let's think about this example. This is saying we have 10 white balls and 10 blue balls, and we're picking 10 balls out of sort of the urn. So it makes sense. This is a plot of the X here, right? I can't highlight it. X is the number of white balls that we get. It makes sense that it's centered around 5, right? Like we have 10 white balls, 10 blue balls, right? Taking out 10 by symmetry, we should sort of get an average of 5 for white balls and kind of symmetrical from there. You can see the minimum is 0, right? The minimum white balls we get is 0. The max is 10, right? It's a slim chance, but we could pick all 10 white balls. Okay, as we decrease the number of white balls, right? So let's decrease the number of white balls. Let's keep N the same and automatically adjust, but we can keep it the same. You can see now we have less white balls than blue balls, and now the distribution starts kind of to move to the left a little bit. It becomes even more extreme if we decrease W. So let's decrease it to 4. You can see now the max here of W is 4. That makes sense. The most balls we can pick out is 4, and sort of the distribution has moved to the left. It's important to pay attention to these axes here because obviously, obviously they're going to change. So now, we can think of it going in the opposite direction if we lower B. So let's say B is 3. Now all of a sudden we have higher possible values for W, for the number of balls. We can also think, I think it's interesting, I went ahead and set back up 10 white balls, 10 blue balls, and 10 draws. If I drag N all the way to 20, I get this weird looking histogram. This is just kind of like a failure, not a failure, it's just like R doesn't really know to deal with what's going on. The reason why is because if I have 10 white balls and 10 blue balls, that means I'm picking out, and I pick 20 total balls out. Every single time, I'm going to pick all the balls, right? Like I have to take 20 balls. There's 20 balls in the urn. I'm going to take them all. That means I'm going to get all 10 white balls and all 10 blue balls at each time. So it means X is always going to be 10, and that's sort of what's going on here. It's just plotting one point. It just covers the whole graph. So if we ever sort of max out this value of N, I'm going to get all values of W. So that's about it. I'll move back to N to something that's interpretable. The only other thing we can do, we can hit go a bunch of times to sample. You can see how it changes, but kind of keeps a similar shape. You can also decrease the number of draws, and if you decrease the number of draws, so here decrease it to 10, you just essentially see more variance, right? So we know what this shape is going to look like as we get a lot of draws over and over and over, but if we go all the way to 10 draws, it's kind of much more variable, right? Just because we have a much smaller sample size. And you can see the x-axis is bouncing around, the shape is super variable. So just an interesting thought about like plotting the number of draws. I thought it would be good to sort of include that for intuition.